Hello friends, we are going to study double stub impedance matching circuit design with the help of a Smith chart. For this, we will see one example that design a double stub shunt tuner to match a load impedance ZL equals to 60 minus J80 ohm to a 50 ohm line. The stubs are to be open circuited stubs and are spaced lambda by 8 apart. Assuming that this load consists of a series resistor and a capacitor that that match frequency is 2 GHz. So here we need to design two shunt stubs which are open circuited and spaced lambda by 8 apart. Now we will see how to design this with the help of a Smith chart. So for this, first you need to draw a topology, and then we need to plot this ZL point on the graph. So for plotting the ZL point on the graph, we need to normalize the ZL. So to normalize the ZL, we have to divide it by the characteristic impedance. In our case, it is 50 ohm. So we need to divide ZL by 50 ohm. So if you are dividing ZL by 50 ohm, we are getting ZL equals to 1.2 minus J 1.6. That is a normalized value of ZL. Now we need to plot this normalized value of ZL on the Smith chart. So we will take a Smith chart and then we will plot this ZL on the chart. So you can see here the ZL is plotted on the chart. So you can see this is the position where we have plotted ZL on the chart. So this is your ZL. Now see, as it is a shunt stub, we need to design with respect to YL. So we need to find out YL, that is the admittance with load admittance. So for this, what we will do? We will just draw the line from center of the graph to ZL, and we will take the compass and take this radius from center to ZL in the compass, and we will draw the circle which is passing from ZL. So this is the circle, and this circle is called as VSWR circle. Now this circle, now your YL point will be on this circle exactly opposite to ZL. So for this, we will draw the line from center at 180 degree from the ZL, that is exactly opposite to ZL, and that line will intersect on the circle, and that point is called as a YL. So this will be your YL point. Now we need to read out the position of this YL point. So if you want to read out the position of this YL point, we have to see the horizontal circle which is passing from YL, that is a 0.3. R is equal to 0.3 circle. Then the vertical Jx value of YL, that will be 0.4. So we can read out this point YL. YL equals to, that is 0.3 plus J 0.4. That is a normalized load admittance. Now what we have to do, as our stubs are placed lambda by 8 apart, then what we have to do here, next we have to construct a rotated 1 plus JB conductance circle by moving every point on G is equal to 1 circle lambda by 8 towards the load. So that means we need to shift R is equal to 1 circle lambda by 8 each and every point on R is equal to 1 circle by a distance lambda by 8 towards the load. And this can be done by using, this can be done like this, that is from the center at a 90 degree, that is at a lambda by 8 distance, we need to draw a line. So this is lambda by 8 because the total length of the Smith chart is lambda by 2. So total length of the Smith chart is lambda by 2. So at total 360 degrees is equal to lambda by 2. So 90 degrees will be equal to lambda by 8. So at a 90 degree from the center, we need to draw the vertical line. So on this vertical line, we need to draw the circle same radius as that of r is equal to 1 circle. Then this circle is called as a rotated 1 plus JB circle. It is rotated by a distance lambda by 8. Now if you observe this circle, then your YL point, that is the load admittance point, is falling inside this circle. Falling inside this circle. Now we have to design both the stub with respect to this YL point. With respect to this YL point. So to design the first stub with respect to YL, what we have to do? We have to move over the horizontal circle, that is R is equal to 0.3 circle, which is passing from YL in the right hand side. Towards on the right hand side we have to go, and we have to go towards on the left hand side. On this R is equal to 3 circle. You can see like this in the actual chart. This is your R is equal to 3 circle, and YL is lying on this R is equal to 3 circle. So we need to move backward and forward on this R is equal to 3 horizontal circle on which your YL point is lying. So when we are moving in the forward direction, this circle R is equal to 3 circle will intersect with your 1 plus JB circle, rotated 1 plus JB circle, and this point of a intersection is called as Y1 point, is called as a Y1. So this R is equal to 3 circle intersects with lambda by 8 circle, and that intersecting point is called as a Y1 point in the forward direction, and the same circle will intersect with a 1 plus JB circle or lambda by 8 circle in the left hand side or in the backward direction also. So that point is called as y1 dash point. This point is called as y1 dash. This point is called as a y1 point. Now at this y1 point, we need to read out a value of susceptance. That is, we can say like jx value of this y1 point and jx value of this y dash point. So we need to read out the susceptance value for this y1 and y1 dash to design a stub. So this is your y1 point. You can see clearly over here. This is your y1 point and this is your y dash point, which is a intersected by R is equal to 3 circle, horizontal circle, R is equal to 3 circle on lambda by 8 circle. Now we need to read out the susceptance, that is the Jx value at y1 point and y dash point. So how to read out the Jx value? We need to find out the vertical circle which is passing from this y1 and vertical circle which is passing from this y1 dash. So we can read out these values. That is y1 का susceptance है 1.7, y1 का susceptance is 1.7. So from this we can find out the possible position of the first stub. So the possible position of the first stub can be found out by finding the susceptance of the first stub. So susceptance of the first stub, how we can find out? We can find it out by subtracting the susceptance of the y1 and susceptance of the yl. So yl का jx value था 0.4 and y1 का jx value is 1.7. So we can find out the susceptance of the first stub, that is b1, is 1.7 minus 0.4, that is equal to 1.3. Similarly, the susceptance of y1 dash, that is 0.28 susceptance, that is the jx value of y1 dash is 0.28 and the jx value of yl is 0.4. So the second possible solution for the stub number 1, that can be founded out like b1 dash, or the susceptance of the second possible stub is b1 dash is equal to 0.28 minus 0.4, that is equal to minus 0.12. Now we need to find out the length related to this susceptance, that is J 1.3 and J minus J 0.12. So that will be the possible length of the stub 1. So the possible length of a stub 1 open circuited stub at plus J 1.3, that is equal to 0.146 lambda, and at minus J 0.12 we can have the possible length is L1 dash is equal to 0.482 lambda. So that can be founded by using a wavelength at that particular point. Now we need to find out a second step. So length of the second step. So if you want to find out the length of the second step, then what we have to do? We have to transform all these points through a lambda by 8 section of the line by rotating along the constant SWR circle lambda by 8 towards the generator. So we need to rotate all these points by lambda by 8 to find out the second stub, because the separation between the first and second stub is lambda by 8. So what we have to do? We have to transform this y1 and y1 dash points by lambda by 8 distance. So at a lambda by 8 distance, which circle is there from this 1 plus JB circle, that is R is equal to 1 circle. So we have to shift this y1 point and y1 dash point on R is equal to 1 circle. So for that, what we have to do? We have to draw a circle passing from y1. So for this what we will do? We will take a compass, then we will take a distance from center to y1 in the compass, and then we will draw the circle. We will draw the circle with this radius, center to y1 radius. We will keep the compass on the center and we will draw the circle. So after drawing this circle, then this circle will intersect R is equal to 1 circle at 1 minus J 3.38. Similarly, what we will do? We will take a compass and we will take a distance from center of a graph to y1 dash in a compass, and we will draw the circle passing from y1 dash. Then this circle will intersect on R is equal to 1 circle at 1 plus J 1.38. Now we need to find out the length of the stub to nullify this susceptance, that is the Jx values. That is to nullify this minus J 3.38 and plus J 1.38. So for this, what we need to do? We need to find out the wavelength at plus J 3.38 and minus J 1.38. So these are the 2 points. Here what we have done? This is your y1. So from this y1 we have taken the radius center to y1, and then we have drawn the circle. That circle will intersect on R is equal to 1 circle at this point. So we can call this point as a point y2, and then we will take a radius. This is your y1 dash. Then we will take the radius center to y1 dash in the compass and draw the circle passing from y1 like this, y1 dash, and that will intersect on R is equal to 1 circle at this point, and this is called as y2 dash point. Y1 is shifted here, that is y2, and y1 dash is shifted to y2 dash. So in this way we are getting the 2 points. Then we need to find out Jx value at y2 and Jx value at y2 dash. So at y2 we are getting the Jx value equals to minus 3.38, and at y2 dash we are getting the Jx value equals to plus J 1.38. Now to nullify this, what we have to do? We have to find out the wavelength at a plus J 3.38 and minus J 1.38 to make them So we are getting y2 is equal to minus j 3.1 minus j 3.38. So if you want to nullify this, what we need to do? We need to find out the susceptance at plus j 3.38, and if you want to, we are getting y2 dash is equal to 1.38. If you want to nullify it, we need to find out the wavelength at minus j 1.38. Now we need to find out the wavelength at the susceptance of plus j 3.38 and minus j 1.38, that is the B2 dash. So the wavelength at 3.38 is 0.204 lambda, that is your L2, and the wavelength at minus 1.38, that is 0.350 lambda, that is L2 dash. So likewise we have designed both the stubs, that is L1 and L2, as well as second possible solution is L1 dash and L2 dash. So likewise we can do the double stub design. Thank you.